Oh, welcome back. We're in Module 2, and we're going to now start looking at working with tables in our database. So that should be interesting. Let's have a look at that.
Let's go.
So we'll start by looking at how we create a table. And most operations that we do in a database, we do using a language called SQL. And we're going to do this using a SQL statement, and it's the create table statement, unsurprisingly. So we're creating a table. And the table name in this case, we're giving it a name, and the name's in two parts. So tell me a little bit about that.
Well, the two parts include the schema, which is really a container that holds the table itself, and then the name of the table. So sales is our schema, and product will be the name of the table. We can put other objects inside the same schema. Related tables can all be in that sales schema, for example. We'll talk more later about things like views and stored procedures. They can all be stored in a schema. So it gives us a way to organize and then later use for a security wrapper as well.
All right, so it's a sort of namespace, but also something I can use as an encapsulator for security. All right, so we're creating this table. Now, when I create the table, you can see in the diagrams appeared above there, there's a table now. It's a fairly amorphous thing because a table consists of columns. So actually, we need to start defining the columns that are in that table. So in this case, I'm defining a column called product ID. Each column has a data type. So what's the type of data I can store in that column? And in this case, I've said this is an integer column. So whole numbers only in this column. It's a special kind of column called identity. And what that means is it's going to automatically increment the value in that column. So you'll quite often see this used as a way of generating a unique key for a row in a table. So we've got an identity column, and we've explicitly said this is the primary key for this table. In other words, this is the column, the value in this uniquely identifies each row in the table.
And only one column can have that identity property, right?
That's right, yeah.
Within a given table. And similarly, only one column can be the primary key unless you've got a composite of multiple keys. But you can't have different columns that are each the primary key.
Yeah, there's only one primary key. It consists of one or more columns, I guess, is the way to think about that. You could combine columns to make a primary key. So we've got our product ID column. The next column we're going to create, we're going to create something called a name column, and it's of type varchar 20. Now let's kind of interpret that a little bit. Varchar? Varying with characters. Varying with characters. So in other words, it's a string value. It's a string of characters, and it can vary. Some maybe only have, some people might, or some products in this case might have names that are only 5 characters long. Sure. They can have any number of characters up to 20. Up to 20. Specifying a maximum. And then we got this this column called price, which was specified as a decimal value. And I've also included the word null there. So tell me a little bit about nulls.
Well, in this case, that allows the column to be null, which is to say we may not supply a price for one of the rows, and that may be because we don't know what it is or because it doesn't have a price.
Right, so we're basically saying we're not enforcing there being an explicit value in this column. We can have a null value that says either there is no price or we don't know what the price is. So we create our table with these 3 columns there. We've got our product ID, our name, and our price. And what I might want to do is, after I've created it, I might want to alter that table and perhaps add an additional column. So we've got this create table statement to create a table, and an alter table statement is used to modify the definition of a table. We're not modifying the data in the table, we're modifying the table itself. So I'm altering the table, and in this case, I'm adding another column called supplier. It's an integer column that doesn't allow nulls. Explicitly, we're not allowing nulls in that column. And I'm also adding something called a constraint. And constraints are something you'll come across quite often in databases. They are rules that we apply to a particular column. So in this case, I'm saying the constraint is that this column has a default value of 1. So whenever I try to insert a value into this table, if I don't specify a value for the price column, which allows nulls, then we'll end up with a null there. If I don't supply a value for the supplier column, which doesn't allow nulls, but does have a default value, then we'll get the default value of 1. That make sense?
Sure. So if we don't know the value, something will be supplied for us.
Exactly, yeah. Now we've looked at create table, we've looked at alter table. The final thing you might want to think about is, hey, I made a big mistake. I don't need that table at all. I can drop that table. And the way you drop a table is drop table. Don't get mixed up with drop and delete. Right. Delete is used to delete data in a table. Drop is used to delete a table, to drop a table from the database.
So we've got create and alter and drop.
Yeah.
Collectively, those are data definition language, right?
Exactly.
DDL.
DDL we'll quite often talk about, yeah. So a couple of points that we've made then, just to kind of reiterate then. You create tables using the create table statement. You specify the name and the column specifications for the columns that are in that that table. You can modify a table definition using the alter table statement. You use that to add or remove columns, constraints, keys, that type of thing. And we can remove tables by using the drop table statement, and that just removes that table from the database. So
now, if there's data in a table and I drop the table, what happens to that data?
you lose the data.
So we've got to be really careful about dropping tables.
Exactly, yeah. You have to be very careful with that.
Is there an undo in SQL Server?
Not for dropping tables, no. I guess you'd have to restore from a backup, which is usually the answer to that particular problem. All right, so we talked a little bit about creating tables then. Let's turn our attention, once we've got these tables, we obviously need to get some data into them. So let's perhaps look at that.
All right, sure.
Okay. Well, we'll go back to our idea of working with data in tables, and we'll go back to our SQL language that we use for doing this. So here's my table. Now, earlier on, I put some sort of italicized values in there just to really show what type of data went in them. In reality, if we just created a table, it's empty. There's nothing in the table. So if I want to insert some data into that, you'll be amazed to learn that
is there an insert command? There's
an insert command. So we actually do insert into the table, and I can insert the values in that table. Here we're just simply specifying that we're inserting these values, and we're just using the location in the values clause there to correlate with the position of the column in the table. Notice I haven't specified anything for product ID. You remember that?
That was the identity column, so that's going to auto number.
Exactly. So when it's an identity column, that's the kind of exception to the rule. You don't have to specify a value for that. And what we've done is specify the values for the other columns. So we've specified the name column, the price column, and the supplier column, and we've given those values. We've inserted a widget at $12.99 into there.
Do the order of those values matter?
It will, because that correlates to because we haven't specified which columns we're inserting into, it has to go with the order that the columns are in the table. And what we can do is specify explicitly which columns we're inserting, in which case we can do it in any order we like. We just say we're inserting into the name, price, and supplier column these values. Now, they happen to be in the same order, but they don't have to be in this case.
And if you left out any column names from the insert list, what happens?
Well, that's where it gets interesting. You might remember we had the idea of our price there that supported nulls and our supplier that had a default value. So in this case, I've just inserted into name. I haven't specified anything for product ID because that's an identity. I haven't specified anything for price, and I haven't specified anything for supplier. So we insert the name knickknack, but then in our price column, we get a null because that column allows nulls, and we haven't specified anything else to go in there. And in our supplier column, it doesn't allow nulls, but it does have a default value. So we get the default value of 1 appearing in there. So the rule is, if there's a default, you'll get the default. If not, and it supports nulls, you'll get a null. If it doesn't support nulls, you'll get an error at that point. So if I do something like insert into product, in this case, I'm explicitly saying null and default. I can do it that way as well if I know I want to insert null and default. But if I do something like insert into product, something like that where the data type's not right, so I've said I want this thing to be free, and I've inserted that as a string, then I get an error because it's the wrong data type.
We need a 0 there instead of the word free.
Exactly. And this time I've inserted a 0 there, but I've specified null for the supplier, and supplier doesn't support a null value. So I get an error in that instance as well.
And that seems to make sense because we need to know what the relationship is to the supplier table for that row. So we can't just leave it out.
Exactly.
We need to know who that supplier is.
Yeah. So we can use these constraints that we place upon the columns in the table to enforce some sort of integrity in the data. It just prevents us from doing stupid things like inserting products that don't have suppliers. All right, well, we've inserted some data into this table. I guess the next thing we want to do is get some data out of it. So let's take a look at that. And the way that we do that is with this idea of a select statement. So we've got select. In this case, I've said select star. What's that about?
That means I want all of the columns.
Right. So it's shorthand for saying just bring me back all of the columns in the database. And because I haven't filtered on the rows either, effectively what I'm doing is bringing back all of the data in that table.
And that's okay for a teaching example, but do I want to do that in my applications?
I suspect you don't. As your tables get larger and as you're accessing this thing over a network, you don't want to be bringing back data unnecessarily. So usually we would advise people don't use select star unless it's a very small table or you're just, you're testing things out. Typically you'll specify the specific columns that you want. You'll specify the specific columns. There you go. I have to talk about tautology. So we're getting the product ID, the name, and the price from the product table in this case. And in my result set underneath, that's exactly what I get. I get those columns.
And the order in which I list them in the select clause determines the order in which they come back, right?
Exactly, yeah. Now, in this case, there's something interesting going on. I've brought back the name product, but I've specified bring back name as product. So I'm giving it a different name in the result set. Notice in the result set, the column is called product, even though the original column is called name. Mm-hmm. And similarly, for the price, I'm not just bringing about the price, I'm bringing about the price times 0.9, multiplied by 0.9. In other words, take 10% off, and that's going to be my sale price.
Well, so we'll have to check with the manager.
Yeah, we may have to check that I've got permission to do that. But notice that it's gone ahead and it's multiplied, where there is a price, it's multiplied it by 0.9 and give me that value. Where the price is null, well, anything multiplied by null is null. An unknown value divided by 10 is unknown, so we get null.
And interestingly, it's null. It's not an error.
No, it's not an error.
It's not like I'm doing an operation on zero.
Yeah, but the default behavior, and you can change this if you go into the settings, but the default behavior is that a null, if you do an operation on a null, any operation with a null results in null. Which makes sense. You know, the price I don't know multiplied by 10 is something I don't know. Now, in this case, I'm applying a where clause, and that's a new thing we're introducing in the select statement at this point to show how we would filter the rows. We've seen how to specify the columns I want. In this case, I'm also filtering on the rows. So bring me back only the products where the supplier is supplier 2. And that's how we do that. And
one of the things that you'll need to get used to, and that's something we cover in more depth in our T-SQL MVA and some of our other T-SQL courses, is the order in which the database engine is interpreting that statement. And so learning that it looks at the from clause and then it applies the where filter before it then selects the columns starts to help you understand, as these statements get more and more complex, what the output's going to be. But we'll keep it small now.
Yeah, exactly. There's an underlying engine, the query engine that interprets the SQL you type. The SQL actually is fairly, I think it's quite intuitive. It's a syntax that's, you could read that and pretty much know what it does, even if you've never done any SQL before. But that's not necessarily what gets interpreted under the covers by the query engine. So some key points we've covered then. We insert data into a table using the insert statement. And when we do that, we can either specify explicit columns or we can support defaults or nulls and insert into those values. We can select data from a table using the select statement, and we do that by specifying the columns or expressions. We had some calculations in there that we can use, and that brings back what we want to get in our result set. We can use aliases or alternative names, if you like, for the columns in the result set. We use the as clause to do that. And we can filter rows using the where clause to bring back only the rows that satisfy that filter criteria.
Mm-hmm. So you've got some demos of this to show us, right?
I have indeed. Let's go and take a look at creating a table in SQL Server.